well, and the work solutions. Okay, so starting today, we're just doing a very little intro to sequences, and the title is Sequences and How to Specify Them. What a sequence is an ordered set of numbers. For example, 2, 5, 8, and 11. That sequence, we're adding 3 each time as we go along from number to number. An infinite sequence is a sequence followed by 3 dots, meaning those 3 dots mean it's going to keep going infinitely, continuing that pattern forever. A sequence may be finite though, meaning that it has an ending, or infinite, meaning it goes on forever. So there is the 2 different types. It could be a finite sequence or an infinite sequence. When a sequence follows a mathematical pattern, it can be described with a formula. We call the first number in the pattern the first term, and the second number in the pattern is the second term, and so on, third term, fourth term. The nth number in a pattern is the nth term. This is called the general term, and we'll be able to write our formulas using n to represent any term in that sequence. Another way to describe this is using the following notation. So the first term, we do a T with a little 1, like a little subscript, just slightly down below, meaning the first term. T2, little subscript, means the second term. T3, and all the way down to Tn, meaning the nth term or our general term. Some sequences, not all, can be expressed in a recursive form, which means each term is found doing something to the term immediately in front of that term. Okay, so like that first one that we have at the top there, where we're adding 3 to the previous term, that's a recursive sequence because we're going to be repeating that pattern to find each one. Most of the ones that we're looking at will be like that, but not all of them have to be. Okay, so with all that information in mind, let's do some questions. Number 1. Write down the first 5 terms in the sequence given by Tn, so that's our nth term, that's our general form of this expression here, the sequence, is equal to 3n take away 5. So we're wanting to find 5 terms, so you always start with when n is equal to 1, 1 being the first term, and we're going to sub that in. So to be thorough, I'm going to show a little bit of working out for the first ones, but you'll probably find pretty quick you'll start to minimize that. So the first thing I'm going to do is I'm going to sub in when n equals 1. That means t of 1, the little subscript 1 means first term, equals, I'm just replacing the n in that equation with the number 1. So 3 times 1 minus 5, and that of course equals negative 2. There's my first term. If I wanted to find the second term, I would be subbing in when n is equal to 2. So it would be a t with a little subscript 2, and this time it would be 3 times 2 take away 5, which is 6 take away 5, which is equal to 1. Now that's going to be pretty painful if you have to do that for 5 terms. So what you'll probably end up doing, we're going to write them over here on the side, as a sequence, our first term is negative 2, our next term is 1, and we might just do a few of these in our head. If I want the third term, 3 times 3 is 9, take away 5 is 4. If I want the fourth term, 3 times 4 is 12, take away 5 is 7. And the fifth term, 3 times 5 is 15, take away 5 makes 10. And you can actually see that there is a recursive pattern there. We are adding 3 each time as we go along in that sequence. Now we could add a comma and a dot, 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 because we could actually find more terms in that sequence if we wanted to, but we found the first 5, which is what we were asked to do. Okay, part B. Describe how each term t of n can be obtained using the previous term t of n take away 1. So when you did these kind of patterns, I don't know, maybe primary school, I don't know, when you did these kind of patterns, very simple ones, remember having these little patterns, we had to continue the rule. You'd do something simple like, all right, we're adding on 3 each time, and you just go, all right, add 3. Okay, that's a little bit too simplistic for where we want to be. We want to put this in terms of our T of n, okay? If I am trying to find T of n, it is going to be equal to the previous term. Now, if n is the term I'm trying to find, the term before it is going to be n minus 1, one position in front of it, and I'm simply adding on 3 each time. Okay, so writing it more as a formula instead of just going, let's just add 3. Question 2. Write down the first 4 terms of the sequence given by T1 equals 7, Tn equals T of n minus 1 plus 11. So that T of 1, it's giving me the first term, 7. Done. Okay? To find the ongoing terms in that sequence, the rule is that I take the term in front of it, this 7 here, and all I have to do is add 11. Okay, so I go plus 11, my next term will be 18. Okay, then I take the 18 and I want to plus 11 to that, so I'm going to get 29, plus 11 to that, and I'm going to get 40. Okay, this one asked for 4 terms, so I've got enough there now. Part B, write down the formula for the nth term, which is T of n, which is also called the general term. Okay, I want to go back and find a proper formula like this one here, for T of n. So if we can find something that we're adding on each time, which we already know we're adding on 11 every time, that's what you actually have to multiply your n by. So it's going to be T of n, my term. I'm going to have to multiply n by 11 every time. But usually you'll find you have to either add or subtract something off there to make that fit the terms that you've got. If I take my first term and I times that by 11, I get 11. So I'm going to have to subtract off 4 to get that back down to 7. Now, keeping that in mind, let's just test to make sure that works. Let's maybe go to our 4th term. If I went 11 times 4, it's 44. Take away 4, I do get 40. Okay, so just a little tip on how to work those out. Whatever they're going up by is what you multiply by, and then either add or subtract something off there to make it fit the first term. All right, question 3. Find whether 165 and 200 are terms of the sequence T of n equals 3n plus 15. So what I'm going to do is I'm going to make T of n equal to, start with the 165 and see if that actually works out to be a nice value for n. N should always be a whole number if it is a term in that sequence. We only ever sub in whole integers. Okay, so taking this formula, I'm going to take the T of n and I'm going to substitute in the 165. So 165 equals 3n plus 15. And now I'm going to solve that and see what n is equal to. So to solve it, I'm going to subtract the 15, so 3n equals 150. And then if I divide by 3, I get n equals 50. Because that worked out to be exactly 50, a nice whole number, that means that 165 is a term in that sequence. And again, if you're double checking this in your head, you could then put that 50 back in here and go, if I want the 50th term, 3 times 50 is 150 plus the 15 is 165. It gives me that value back. So let's just write a little conclusion there. Therefore, 165 is a term in the sequence. All right, let's try the other one. We had the value 200. So same process, let's put that where the T of n is. 200 equals 3n plus 15 and solve for n. Subtracting 15, we will get 3n equals 185. And dividing by 3, I can hear the calculators coming out, good. It is 61.67 or 2/3. But the point is, it's not a whole number. Okay, because it's not a whole number, it means it is not a term in our sequence. So therefore, 200 is not a term in the sequence. it would be a number between the 61st term and the 62nd term. It would be between those two terms. All right, question 4. Find how many negative terms there are in the sequence t of n equals 8n minus 140. If it's asking for negative terms, I'm trying to find when my term, my t of n, is less than 0. Now my term, instead of calling it t of n, the t of n is equal to 8n minus 140. So let's replace that. 8n minus 140 must be less than 0. And I'm going to solve that inequality. So add the 140 across. 8n is less than 140. And dividing by 8, you get 17.5. Now that means that 0 is actually not a value of this sequence. If I got a nice whole number there, it would be right on 0. But I want to know the very next number will make that, the next number bigger will make it positive. I want the one smaller than that, which will keep it negative. So the 17th term will still be negative. The 18th term will not be. Okay, does that make sense? So I'm going to say, therefore, there are 17 negative terms. And part B, very similar, we're now just wanting to do positive ones. So it says find the first positive term of the sequence t of n equals 6n minus 45. So that is going to be when t of n is greater than 0, because positive is greater than 0. And I'm going to solve that inequality. Replace the t of n with the 6n minus 45, greater than 0, and solve. So 6n is greater than 45, moving that across, and dividing by 6. Is anyone doing this with me? Excellent. So 7.5. So how many, where is the first positive term? The 8th one, right? So if I go to 7, it's still going to be negative. So I need to go to the 8th term to make it positive. However, this question was worded slightly different. Let me just write that down. Therefore, the first positive term is when n equals 8. This question actually said, though, to find the first positive term. To find the position is not enough. I actually want to know what that term is. So I then need to come and find, I sub in t with a little 8 to find my 8th term and sub the 8 in for the n. So 6 times 8 minus 45. 6 8s are 48, minus 45 makes 3. So it's just gone into the positive. All right, that's it. That is exercise 1A. Nope, just A.